Okay, hello everyone. All right, so the next program in chapter 6 is freezing and boiling point. All right, so the following table lists the freezing and boiling points of several substances. So substance, you have ethyl alcohol, oxygen, and water, and it tells you their freezing point and boiling point. So design a class that stores a temperature in a temperature field and has the appropriate accessor and mutator methods for the field. In addition to our appropriate constructors, the class should have the following methods. So we have a bunch of methods over here. It's ethyl freezing, for example. This method should return the Boolean value true if the temperature stored in the temperature field is at or below the freezing point of ethyl alcohol. Otherwise, the method should return false. So if someone, for example, the person running a program, let's say, provides, so actually they gave an example down here with water. With water. So basically these methods are similar. All the details are there. We'll get to it. Write a program that demonstrates a class. The program should ask the user to enter a temperature and then display a list of the substances that will freeze at that temperature and those that will boil at that temperature. For example, if the temperature is -20, the class should report that water will freeze and oxygen will boil at that temperature. So over here we can see that -20, okay, is way less than the freezing point of water, right? So in that case, it will say that water will freeze at that temperature, and we can see that -20 over here. Where is it? Where is it? I can't see it. So over here, we're saying that if the temperatures, the class should report that water will freeze and oxygen will boil at that temperature. So we can see that it will boil at this temperature. Okay. With regards to oxygen. So we'll create this, right? So basically, we're going to create methods in the class and all that stuff. So let's go ahead and start. So I'll create the class. The class. It's going to be a public class. Public because again we want this. I'm saying again because I've mentioned this in my other videos. Again, nothing bad there. Public class. Okay, it's a public class because we want this class to be available to code outside of this class. Any code that's different from this class, we want this class to be accessible to that code. And I'm going to call this class. Did it say we should call? Yeah, it says design a class that stores the temperature. It didn't say, okay, so they didn't say we should give it a name here. Let's call this class. Let's just call this class temperature. Or let's just say freeze boil or something. Freeze or boil. Let's call this class freeze or boil. All right, and then now let's go ahead and create the fields for this class. I'm going to create a private field. It's going to be a double, and I'll call this field temperature. Private because I want this field to be hidden from code outside of this class. I don't want code outside of this class to be able to directly change the content of this field, or I don't want code outside of this class to be able to access or see the content of this field. I want them to use I want the code outside of this class to use other means to see the content of this class or to change the content of this class. I don't want code outside of this class to directly see the content of this class or change the content of this class. All right, so we are hiding it. It's data hiding. So this class is only going to have one field, the temperature field. And then it's going to have instance methods, these instance methods here. Also, it's going to have accessors and mutators. So let's work on the accessors and mutators for this particular field, right? So the accessor, let's start with the accessor. The accessor is going to basically get the value of this field. And it's going to be an instance method. Instance methods don't have the keyword static. Okay, for now, just know that instance methods don't have the keyword static. An instance method is a method basically that works on the field of an object that works directly on the field of an object created from this class. So because this instance method is going to get the value of this field, okay, of this class, it's an instance method because it's working directly on the field, okay, of an object that's going to be created from this class. It's an instance method, and instance methods don't have the keyword static. For now, just know that, and as we move forward, we will learn more about it. But for now, just know instance methods don't have the keyword static. All right, so it's going to be, apart from that, it's going to be like a regular method. So I'm going to go ahead and create a public method because I want code outside of this class rather to use this public method to access this field instead of being able to see the content of this field directly. So I'm making it public. So public, I need to specify the return type. Now this method is going to get the value of the temperature field. Okay, so we know that the temperature field is going to be returned. So I'm specifying the return type of this method to a double because we know the temperature, which is a double, is going to be returned. So I'm specifying it to a double, and then I'm going to call it get temperature. I don't think we would actually need it. Well, we wouldn't actually need it in this program. We wouldn't. We would actually need a mutator rather to set it. But let's define it all the same. So the get temperature basically is not going to need any arguments. So I'm not going to define any parameters. Once this method is called, all it's going to do is it's going to return the value of the temperature field. That's all it's going to do. All right, so now let's go ahead and create a mutator for it, which is going to set the temperature field. And the mutator is also an instance method. It doesn't have the keyword static. So let's call that set temperature. And set temperature is going to need an argument. So I'm going to go ahead and define a parameter. And the argument is going to need is the new temperature that is going to be set. Okay. So if you're setting the temperature, then you need a new value to set to, to replace the old one. So the new value we are going to use is what I'm defining a parameter here for. I'm defining a parameter here for the new value. So I'm going to say the new value temperature is going to be a double, right? So I'm defining it as a double, and I'm going to call it temperature given or new temperature. I'm just temperature given is fine. So once we have that temperature given, we're not going to return it. What we want to do is we want to set the temperature field, what's already stored in the temperature field, to the temperature given here. Okay, so now that's all this method is going to do. It's going to we know it's okay, so because I copied and pasted, I also have the return type as a double. This method is only going to set the temperature field. It's not going to return anything. It's going to set the field of the temperature here. I mean, this temperature field here. So it's not going to need any return type. It's not going to return anything. So because of that, its return type will be void because it's not returning anything. But over here, it's returning the temperature. So we have to set a return type to a double. So if we set that, if we pass in a value here, it's going to set the temperature field to the new value given. So let's see if I did it correctly. Temperature. All right. Okay. All right. So now we're done with the accessors and mutators, right? We have an accessor, we have a mutator here, a getter and a setter. Now we have to go ahead and create the other instance methods, which are these, right? So the first one I'm going to create is, they're all instance methods, okay, because they're going to work in on the field of this temperature field. They're going to use it to do stuff. Instance methods don't have the keyword static, so public, no keyword static. I need to specify the return type. Now over here it says this method should return the Boolean value true. Okay, so we know that this method is returning something, and it's returning a Boolean value. So let's set the return type to be a Boolean. So public Boolean, right? And let's give it, name it. The name of the first one is going to be ethyl freezing. It's ethyl freezing. Okay. And this method is not going to accept any argument. All it's using is the value stored in the temperature to return something, right? So it's ethyl freezing. Over here it says that the method should return the Boolean value true if the temperature stored in the temperature field is at or below the freezing point of ethyl alcohol. So let's see over here. Okay, so now we need to go ahead and create an if statement in this method over here. So we can basically ask or check that condition. Okay, so it should return a boolean if the temperature stored if this temperature field here. So if the temperature, we have it here. So the temperature field is at or below the freezing point of ethyl alcohol. So if the temperature is below the freezing point, is less than the freezing point of ethyl alcohol, which is minus 173, right? Then we should go ahead and return true, right? So that's what this method is going to do. Actually, less than or equal to, because it said that if it's over here, it said if the temperature stored in the temperature field is at or below the freezing point of ethyl alcohol, then we should do that. Okay, at or below. So if it's less than or equal to minus 173, then go ahead and return true, because it said should return Boolean value true if that's the case. So that's all this method is going to do. So let's copy it, and because the other ones are going to be very similar, paste it and then complete the second one. So then the next one is going to be ethyl boiling. Let's just change the name. Oops, I realized I missed an L here. All right, so it's ethyl, not freezing, but this time boiling. Okay, so it's ethyl boiling. Let's see what it says over here. The method should return the Boolean value true if the temperature stored in the temperature field is at or above the boiling point of ethyl alcohol. If the temperature is greater than or equal to the boiling point of ethyl alcohol, and we know the boiling point of ethyl alcohol is 172 here. So if it's at or above, this is 172, not minus. So if the temperature is greater than or equal to 172, then return true. We're going to do the same thing for the other ones. So let's just read and then complete it. It's oxygen freezing. Let's just change the name to oxygen freezing. So if the temperature is at or below the freezing point of oxygen, so we can basically follow the the idea and get it done. So if the temperature is at or below, is less than or equal to the freezing point of oxygen, which is minus 300 and minus 362. Then return true. Okay, and then let's work on the next one. The next one is going to be oxygen boiling. So change this from it's oxygen freeze. Basically changes to it's oxygen boiling. And that's if the temperature is greater than or equal to the boiling point of oxygen, which is minus 306. Okay, so let's work on the next one, which is water freezing. If the temperature is less than or equal to the freezing point of water, which is 32. And then the last one is going to be water boiling, I guess. Yeah, it's water boiling. If the temperature is greater than or equal to the boiling point of water, which is 212. Return true. Okay, so now we have those methods ready. All right, so now let's go ahead and create a constructor for this method. For this class. The constructor is also a regular method. It's going to be a public constructor. It doesn't have the keyword static as well. It doesn't have a return type because we do not explicitly call this method ourselves. This method is called when an object is going to be created from this class. So because we do not call this method ourselves, it can't return anything. And because it can't return anything, we do not specify a return type. It's just going to be public and then the name of the constructor. Now the name of the constructor also has to be the same as the name of the class. In this case, the name of the class is freeze or boil. So I'm going to create a public constructor, call it freeze or boil. No static keyword, no return type. And apart from that, it looks just like a regular method. Freeze, let's see. So I'm going to go ahead and create one constructor that's going to accept an argument, right? You can go ahead and create a constructor that doesn't. But I'm going to go ahead and create a constructor that's going to accept the temperature as an argument, so we can set default values. Instead of well, we have a mutator here. We can use that too. But let's just create a constructor that's going to be able to set a default value for the temperature field. So I'm going to create a parameter for the temperature field. I'm going to call it I'll call that one to temperature given, right? It doesn't matter if the name is the same as this one, because the scope of these variables are within their individual methods. The scope of this variable is only functional in this method. That's it. So you can use the same name in another method, and they will be seen as two different names because they're in two different methods. All right. So public freeze or boil. I'm going to define another double field for, and I'm going to call it temperature given. And once someone creates an object, we are going to set the temperature field to be equal to the temperature given. Okay. And I think we're good for now. We have one accessor, one mutator. We have all the methods. We have a constructor. We can go ahead and create multiple constructors to handle different cases where we have to initialize fields, where we don't have to initialize fields. We can do that, but this constructor should be fine. So let's go ahead and compile this and then save it in, this was the previous program. Let's create another folder in chapter 6. I'm going to call this, I think it's freezing or boiling points, right? Freezing and boiling points, I'm not sure. Let's just call it freezing. I'll call it freeze and boil. And then save this as freeze or boil. If it does end, save this as freeze or boil .java. Okay, we have a couple of errors, so let's try to fix it. Missing return statement. All right. Yes, that's true. That's true. We, for the methods, I'm sure some of you saw it, if not all of you. The methods, we set the return type to be Boolean, right? Although we are returning true over here, this is only going to return true if this condition is true. What if this condition is not true? Then that means it doesn't return anything. So we have to make sure we set a return type for every case. So if this condition is true, then return true. If not, then let's go ahead and return false. As soon as one of these statements run, so for example, as soon as one of the return statements run, it exits out of this. It's done. This method is done running. It's not going to run this and run this at the same time. It's only going to run one return statement at a time, so it's fine. If it's true, it returns, and then that's it. It returns out of this. It's done. It's done with this method. And then if this is not true, then the false is going to be returned. So let's do the same thing for the other ones. So let's go ahead and copy this and paste it in each one of the other methods.